All right, section 17b. This should be the end of. Actually, like I said, I might take another day to go over this, but we're gonna do some more square root stuff, radicals, and we're gonna combine them with a fraction. Right. So, for instance, what if I had this one? Oops, let's change this to a little thicker. 1 over square root of x. And you look at that and you're like, well, okay, what's up with that? I can't do anything with that. The square root of x, I can't really mess around with that or anything. But for some reason, somebody said that this is not simplified. All right? It's not simplified because you have a square root in the denominator. Do you remember that from Algebra 2? Yes? No? Do you remember them talking about that? So it's not simplified when you have a square root in the denominator. I've actually looked this up, and I still haven't really come to a really good conclusion on why that's not simplified. It's just somebody who makes the rules said this is not simplified when you have a square root in the denominator. Okay, so we have to simplify this, and that's what they're going to tell you to do. They're going to tell you to simplify this expression, I guess they would call it. All right, so this is not simplified. Why is it not simplified? Because you have a square root. Actually, let's just write square root. You have a square root in the denominator. All right? Denominator. All right, so if you have a square root or any radical in the denominator, they consider it not simplified. So we got to figure out how in the world are we going to get rid of that square root in the denominator so that it is simplified, and that's what we have to do. Now let's go back in time a little bit, just recent time, and we've talked about this before. Remember this? If I said like the square root of 3 times the square root of 3, without actually doing the math, you should just look at this and what's going on here. The square root of 3 times square root of 3 is just what?
3.
Just plain old 3, isn't it? Remember that? If you wanted to do the math, you could. It would be the square root of 9, right? And the square root of 9 is 3. But then I said, remember, it could be a little more complicated numbers as well. Square root of 17 times square root of 17. I don't know what 17 times 17 is off the top of my head. And then I sure probably couldn't find the square root of that big old number. But if I look at it, a square root times itself is just that number, isn't it? It's just a 17. Look, I could have some big crazy number. The square root of 283 times the square root of 283. Do I have to do really any math with that at all? No. Okay, it's just what?
283.
Just 283. It's just the whole number, 283. So look what we did. We had a square root. How did I take that square root and actually turn it into a whole number? What did I do to that square root? Multiplied it by not just any old square root, but by its what? By itself, right? Okay, I multiplied it by itself. Are you starting to see what I might do over here? Okay, because watch, let's rewrite this again. Remember what I said, I can't have a square root in the denominator, can I? So, I need to get rid of that square root. How can I get rid of a square root? Well, if I take a square root and multiply it by itself, I get a whole number. So Leslie, tell me what I'm going to do. No, because it's not a negative exponent, so you don't really want to flip it. Jared, what do you think? Yeah, technically we are squaring it, but there's no rule that says whatever we square on the bottom, we square on the top. Okay? For instance, if I... No, let's not do it for instance. Let's just stick with this one. I'll just show you. Okay. If I have the square root of x right here, remember, I want it to be a whole number, don't I? So what do you think I can do with that square root of x to get it to just be an x? Multiply by the square root of x, right? Would you agree? Okay. So I multiply by the square root of x. So what's the square root of x times the square root of x going to equal? Just plain old x. But can I just do this? Can I just multiply something by the square root of x? No, that's going to change the whole entire value of that fraction, isn't it? It's not the same thing. Because 1 over x is not the same as 1 over the square root of x. Okay, what do you think I'm going to do? Common denominator stuff. That's right. So why can I do that? I made that in yellow for a reason.
Because that equals 1.
Very good. That's what I want you to see. Everybody see that? Because when I have this something over itself, when I have something divided by itself, that's equal to the number 1. All right? If I take any number in the world and multiply it by 1, have I changed the value of that number at all? No. I could take anything, multiply it by 1, and it's always itself. Right? You remember that when you're a little kid. So what I've done right here is just basically just multiplied by a 1. I haven't really changed the value, but look what happens to it now. What is the square root of x times the square root of x? It's just plain old x, right? And then look at the top. 1 times the square root of x is square root of x. So look what I've done. Now, it doesn't look like it's more simplified. It looks like it's more complicated than what we started with. But it is simplified. Why is this simplified and this not simplified? What do you think? Yeah, that's right, because you don't have a square root in the denominator anymore. We're allowed to have a square root in the numerator, in the top, but we're not allowed to have it on the bottom. Everybody see that? So we took this, we simplified it, and now we get square root of x over x. It's the same exact thing. For instance, if I went, let's stick a real number in here, the square root of, let's say 5. 1 over the square root of 5. And let's see how we can simplify this. I'll stick with the same color scheme here. So this is not simplified. It's not simplified because you have a square root in the denominator. So how do we get rid of that square root? Well, we multiply it by itself. And then I do the same thing to the top. Why did I do it to the top and the bottom? Because it's a 1. Everybody see that? There's really not a rule. You know how in algebra you had that rule, whatever you do to the left side, you do to the right side? There's really not a rule that says whatever you do to the bottom, you have to do to the top. Because if I added a 3 to the top, and I added to the bottom, and then I added a 3 to the top, that actually changed my value. For instance, what if I had 2/5? What if I did this? What if I added a 3 to this, and I added a 3 to that? Is that still the same value? No. 5 over 8 is not the same as 2 over 5. Do you see that? So there's no rule that says whatever I do to the bottom, I have to do to the top. So somebody earlier said square it. No, let's do that 2/5 again. If I had 2/5, some people think this is the rule, but it's not. Okay, I almost hate to write it, so I'll put an X through it. I almost hate to write this down because people will remember what I tell them that's not true. But watch, if I square, if I square the bottom and I square the top, what do I get? I get 4 over 25. Is 4 over 25 the same thing as 2 over 5? It's not. Put it in a calculator. You'll see it's not the same thing. All right? So there is no rule that says whatever you do to the bottom, you do to the top. Everybody understand that? So that doesn't work. And the reason I'm taking so much time to talk about this is because I've seen over the years that kids have a tendency to think that, oh, whatever I do to the bottom, I do to the top. No, no, no. That's not the rule. What is the rule? The rule is I multiplied by the square root of 5 on the bottom, and I multiplied by square root of 5 on the top. What did that make that? That made it a 1. That made us multiply by a 1. Look at this thing right here when I added a 3 over 3. I didn't add a 1 there, did I? All right? No. It's completely different. This right here, it became a 1. I know I probably went a little too long on that, but I think it's important that at least I tell you, whether you understood it or not. Hopefully you did, but if you didn't, at least I told you that that was the reason. So let's finish this up. Let's do the bottom. I always like to do the bottom first. I don't know why, but square root of 5 times square root of 5 is just plain old 5, and then multiply the top, and it's square root of 5. All right, and that's it. Put that into a calculator. And I'm not going to take the time right now, but you can put it into a calculator and see if it's the same thing. Put 1 divided by the square root of 5 and get some decimal number, and then put square root of 5 divided by 5. You'll get the same exact number. It won't even be off any decimals at all. It'll be exactly the same number. Okay? Try it and you'll see. So that and that are the same thing, but this is simplified. Why is this simplified? Because you don't have a square root in the denominator. Make sense? All right. Let's do one a little bit more challenging than that. Because you want to be challenged, don't you? Wow, that was a rousing answer. Alright. Let me find a good one. Let's do this. I'll tell you what. Let's do a little easier one, and then we'll work our way up to this. This is basically the same kind of problem, but I stuck a 4 up here instead of a 1. Right? So what do you think we're going to do? Think about it. Don't just let me do all the work. You should be sitting there thinking about the very next step. Okay? A lot of people with their eyes closed and heads down. You're not going to learn it that way. It's going to be difficult.
Square root of 3 over the square root of 3.
Very good. So you take the denominator, you have to get rid of that square root of 3, so I multiply it by a square root of 3. I can't just do that to the bottom, I do it to the top. Not because of a rule that says whatever I do to the bottom, I do to the top, but because I multiply by a what? A 1. That's right. So that's the reason that we do that. So now let's go ahead and figure this out. Square root of 3 times square root of 3 is just plain old 3. All right? And then what do I do here? Yeah, then I just write 4 square root of 3. Everybody see that? That's it. Simple. We just stuck a 4 there instead of a 1. Same thing, though. Got it? All right. Let's do one a little bit trickier. We're going to do the 4th root of 3 over 5. Okay? So, what in the world? First thing I'm going to do is this. I don't like a fraction under one root like this, so I put the root on the top and the root on the bottom. So what I'm going to do is just rewrite this. I'm going to write the 4th root of 3 over, what do you think? The 4th root of 5. Very good. The 4th root of 5. Do you think that's simplified right there? No, because I have a what? It's not a square root this time, but it's a 4th root. I got a root. I have a radical in the denominator, and for some reason they don't like you having radicals in the denominator. All right, so we have to get rid of it. Let's do some different color. So let's see what we can do. How do you think I could get rid of this?
Multiply by 3 over 4.
You're right. Let's think of that way. Tiffany was saying this. Let's backtrack a little bit before I start trying to do this problem right here. Remember what I'm trying to do. I'm trying to get rid of that root. Would you agree? Now, what did we do over here? We multiplied by the same thing, didn't we? What if we multiplied by the same thing here? And Tiffany suggested this. It's the 4th root of 5. It might be easier to multiply than... Actually, we could still multiply it like that, couldn't we? Yeah. What if I multiplied it by itself? What if I took the 4th root of 5 and I multiplied it by the 4th root of 5? Because that would be our instinct, wouldn't it, from over here? Because what did we do? We multiplied it by the same thing, didn't we? All right. Will that make this? Will that get rid of our root? No, because, watch, we'll get the 4th root of what? 5 times 5. And what's 5 times 5? 25. That's not got the 4th root of 25 doesn't come out even, does it? All right, so that's not going to work. And that was probably our initial thought, wasn't it? Was just to multiply it by itself and it would just get rid of the root. But that's not going to get rid of the root. All right, so we have to think of something. Let's do what Tiffany was saying. Let's say instead of the 4th root of 5, let's write it 5 to the 1/4. Okay? Oh, I see what you're saying with the 3/4 thing. So how could I get this? What can I multiply this by to get just a 5? 5 to the what? To the 3/4. Do you see that? What's another way to write 5 to the 3/4? It would be 5 to the 1/4 cubed, right? Or you could write it like this. I know I'm going a little quick, so what you would do is you would write the 4th root of 5 cubed. Do the same thing to the top, 4th root of 5 cubed, and we ran out of time, so let's finish this up tomorrow, okay? So we'll start this problem again from scratch tomorrow, and then maybe I'll think of a better explanation than what I did right there. So I won't give you any homework tonight. We'll give it to you tomorrow.